Yeah, so I wanted to present this paper because I felt a lot of us are working on similar things now when we talk about understanding what the model is doing and comparing that to what the model should be doing according to a human. Now, I thought the paper actually presents quite a simple idea, but that we've been discussing a lot, and I feel it's quite smart to have made, well, an entire paper out of this idea. So it was quite interesting to me. So, well, again, they say that we want to be able to use a model. So either for a developer to debug this model or for an end user to, yeah, for instance, be able to appropriately rely on it. We need to understand how it's functioning or what's its reasoning. And so they say again that we have all these different kinds of explanations. In their paper, they focus mostly on computer vision and NLP. So they talk about saliency maps, or in NLP, the explanations that also highlight a few words in a sentence that are important for the model. And so they say that these kind of explanations are not good enough to understand the model reasoning because it's, well, hard to interpret them. So we have, again, well, local explanations, but we would need to look at a lot of them to make sense of them, which is time consuming. And it's also unclear what exactly the model is doing. For instance, when you just look at the saliency map, you don't know what exactly it's referring to. And so they say if we only rely on this, well, we will misinterpret the model reasoning and then, yeah, maybe not appropriately rely on it, for instance. And so instead, what they propose is this framework called shared interest, which is a method and a user interface to directly compare, well, these local explanations to what a human would expect the model to be doing. And then in the paper, they, well, use this framework on 8 data sets, I think, and try to see what kind of insights they can get from the framework on these data sets. And then they also do some user studies with experts and domain experts and developers to see how usable in practice their framework is. So the framework is mostly constituted of metrics, actually. So they say that on one side, so what is the G here? You can get the ground truth about the features a human would expect the model to look into. So for instance, on the image on the right, if the label is mountain bike, well, you would expect the model to look into the bike part of the image. So what's put in the yellow box. And on the other side, you have what the model is actually looking into. So in the case here, since it's computer vision, they use these saliency maps that they threshold on, yeah, some threshold to decide where to, yeah, which zone to actually look at. And based on these two areas in an image or for a sentence, they make several different kinds of metrics. So the first one is this intersection of a union coverage. So basically, they look at the intersection of the two zones and they, yeah, divide it by the total area. And then they have two others. So this ground truth coverage, which is more or less what you could call recall in other domains. And then the saliency coverage, which would be corresponding to the precision. And so the framework basically is simply these 3 metrics that they then applied, well, to these different use cases and did some analysis. And later in the actual user studies, they, well, create an interface based on the metrics as well and give this user interface to different kinds of stakeholders. So this is the kind of analysis they did with the metrics. For this example, they used ImageNet and they look at the predictions, whether they are correct or not of the model. So here, for instance, it's a correct prediction. And then they compare the 2 areas, so the ground truth and the saliency of the model, and make different categories. So when the prediction is correct and while the 2 zones are well aligned, they say that it's a, yeah, human aligned kind of sample. And then they continue with all the correct predictions and they make 3 other categories. So if you have a partial overlap, so for instance, this first use case, you have the saliency part, which is just a subset of the actual ground truth. Yeah, that's what they call sufficient subset. And then in the paper, they discuss when this can happen based on the use case they looked at. Instead, while the model is looking at something completely different from the ground truth, they call that sufficient context. And again, they reflect on whether maybe the ground truth is incorrect, or maybe, yeah, just the model picked up on spurious correlations, for instance. And they continue with the other use cases. They do also the same when the prediction of the model is incorrect. Yeah, so when it's incorrect, but actually it looks like it's using the right concept or areas of the image, they talk about confusers. And then, yeah, they go on to list the other cases. Yeah, and so then they discuss this in the paper, and then they run these user studies. So 2 of them, one which is with domain experts, sorry. So they give this model, in this case, which is, yeah, predicting whether on the image there is I forgot what kind exactly of image it is, but whether it's a benign spot or not, let's say. And they just give this interface where you can sort the images depending on the different metrics and the different categories that they created. And so they let the domain experts explore and define whether they would trust the model, rely on the model, and just, yeah, see what are their impressions. And then they do the same for, yeah, person who would try to develop their model. I forgot exactly what they discussed, but they mostly explain what are how they actually use these different categories and ranking possibilities and metrics, and show that it's helpful to actually decide whether to rely on the model overall. Yeah, and so then they don't do a user study, but they say that you could also use the interface in a even more interactive way, let's say. So instead of just having all the images already annotated with these ground truth annotations, you could also, well, let the user annotate by themselves, either the ground truth or whatever they are thinking about. So for instance, here they have this image of a dog. So you could highlight the pixels of a dog and see what would be for the model the closest class. And then they were saying, for instance, instead, if you would highlight the shoe, even if when you train the model, the label was dog and not the shoe, you would see whether the model sort of learned concepts which are related to shoes, because maybe in that case, it would still, if you highlight these areas, it would still output some classes which are similar to shoes, maybe clothing more general. They give some examples, and I think there are lots of screenshots also in the paper at the end about that. Yeah, so I think that, that's what they call what if probing, which would be another kind of interaction with these metrics and explanations. Yeah, that was all, but I think, the idea of the paper is quite interesting. It's these different categories are more or less what we've been discussing a lot, like whether the features or concepts the model is using are complete or not and correct or not, but just better categorized.
Yeah, actually, I have one question for that. So I think based on these metrics, it's mainly align the humans' understanding of this task with their system's understanding of this task.
Yeah.
So when it's aligned, we can suppose users will have a very high probability to adopt the AI advice.
Yeah, so the thing is, I think in the user study, they are showing still people look at the So here you can see on the interface here. So they show the distribution. So how many images are in, I think they showed, yeah, you can choose the categories here. And so you can see, yeah, probably how many images are in each category. So it's not like you will only have human allied images for a use case. So then they were saying that the domain experts, they were starting probably by looking the human aligned images and starting to, yeah, I think the model is using the right features, but then they would also, yeah, look in more detail into the other categories and, yeah, actually start to think they might not want to rely on the model, but they were not going into much more detail in what to do next, let's say.
Yeah. Yeah, but when I think about this, because you know that the machine learning models will make correct prediction, even if it's not aligned
Yeah.
with the humans' concepts. So actually, I'm thinking
That's what this.
if we try to align, say, humans' understanding of this with machine learning understanding of the image, like, then actually we can achieve a very maybe high accuracy.
Yeah, so at some point in the user study, they say they have a case which is, I think, sufficient context. So a case where, according to a human, this would be the zone to, yeah, use to make the prediction, but the model is looking at something totally different. And so they were saying that sometimes the doctor would actually see that and think maybe the model is just seeing something that we don't know yet is important or can be relevant. So they were not saying for sure you have to align the two because the ground truth is also questionable.
Yeah, yeah, and I'm thinking because we expect the human AI team to be complementary. That means the AI systems can deal with some tasks humans are incapable of. So I'm thinking when it's appropriate to find it's not aligned, when we should find it's aligned.
Yeah, so I guess, I mean, at least for this paper, the idea is just to be able to explore the different kinds of images faster. I mean, because they are already sort of categorized, but then, yeah, I mean, they let it free to interpret it as you wish. So,
and I guess like much like all the other discussions we've had in some of our other works, right, where we try to aggregate and come up with an average human understanding, all those inherent biases with who these people are, what are their demographics, what is their average, and therefore what is the average human understanding shapes everything else, right, over here. Um, so the sort of, I mean, yeah, it looks like a very nice framework of treating these things, but I agree with your observation, Agathe, that this is very similar to the kind of things we've been talking about, right?
yeah, I mean,
So wouldn't this have the same problems as well with respect to who the users are and what the average human understanding is? So that still sort of remains, right? It's a nice way to capture it.
I mean, for instance, yeah, when they were doing these user studies, I was thinking if they would give this use case to the developers, so the one which requires this domain expertise, probably the developer wouldn't be able to reflect on whether the ground truth makes sense or not, or yeah, whether the model might actually really be looking into something which is more relevant.
Okay. So is that what the what if probe was?
Not necessarily, but also just this interface here.
Okay.
They were first I mean, there are two user studies they mentioned, one with domain experts and then one with developers.
Okay.
But I don't think the developer would really know how to reflect on the different patterns if they don't know what can be really relevant. I mean, yeah.
And I think context is the super difficult challenge over here, right? Because in some cases humans tend to use context and some they don't, right? We don't. So if that old example of kimono, I don't know if you still remember this. I shared it at some point in our work some years ago where we were trying to do something similar and try to build an average human understanding over images. We had like these Japanese women who were, there was this image with Japanese women standing in kimono robes, and there were some of the best image classification algorithms. I think it was VGG and something else back then, ResNet 19 or something, and they were sort of focusing on uh, just the kimono parts of the robe, right, of the image. But humans, of course, could also draw inferences from the fact that, hey, this is an Asian face and they're dressed in a robe, so therefore this could be a kimono, right? Um, so I think that contextual understanding is also something that's challenging to get
Yeah.
correct all the time. And I wonder whether we can. So over here, I see this sufficient context dependent. Can you say a little bit about what this is and where they're getting this from?
Yeah, I mean, they say that ideally you would have an expert, yeah, making the work of actually annotating each image. So making these yellow bounding boxes to,
I see.
yeah, tell you what should ideally the model should ideally look into. And then the orange areas are saliency maps. I mean, the salient areas showed by a saliency map actually.
Okay.
So then they can, yeah, just make the comparison per sample.
Interesting.
I was also reasoning on those two different, on the sufficient context and the context dependent. And I
Yeah.
was thinking about the well-known picture of the husky with the small background, which
Yeah.
is labeled as a wolf. And I was wondering in which of these categories it will probably fall. Because I think that, let's say it depends on the label, but it's not that intuitive, to be honest, because one could say, okay, if I change the background, probably the model is gonna label it properly, and then it's context dependent. But in the end, if the label is already correct, then it probably falls into the sufficient context, right? So I was trying to think about how this classification would apply in this case.
Yeah, I guess it depends whether you believe that context is a relevant feature or not. I think in their case, they seem to assume at first that context is not relevant, but then they say that once you see that it actually leads to a correct prediction, you might actually want to reflect on that and yeah, incorporate it there.
I'd be very curious on that same image, or well, a very similar image, because people also use snowmobiles on sand dunes. And so if you swap the snow for sand, what is that model going to do? Because the thing with context and the like driver behind this is I don't remember exactly what the target it was trying to identify was, but the model learned just to look at the background. And so it never figured out what the actual item was. It would just, oh, it has this background, it's this thing. That's kind of what's happening right there with that sufficient context. So if you change the context, but it would still be effectively the same thing that's trying to identify, would it then become a distractor? Like, yeah.
Yeah, so depending on the data set, depending on how you train the model, for sure, all of these different classification maybe have to be wrangled a little bit.
Because these, so on that qualitative, the different labels, the human aligned, the et cetera, that's actually human, like
Yeah.
determined, right? Yeah.